Let's see working set model to avoid thrashing. Okay, so working set model is based on the locality. The model uses working set window delta. Okay, so what is working set window? It is the most recent page references, the most recent delta page references. Okay, so if you can see this particular page references, this during this particular time t1, so you can see that 2 1 2 6 1 5 7 7 7 7 5 1. Okay, so these are the pages that are referenced during this particular time t1. So its working set window is 1 2 uh, 5 6 7 1 2 5 6 7. Okay, so then working set at time t equal to 2, the number of page references are from this particular point. Okay, if you take this is a working set window, then you will get 3 and 4 from this point to this point. Your working set window at time t, working set at time t equal to 2 is 3 and 4. The most recently used page references are 3 and 4. Okay, so the set of pages in the most recent delta page references, we will call it as working set. Okay, so the working set is approximation of programs locality. If a page is in active use, then it will be in the working set. If the page is no longer being used, then it will drop from the working set. What is mean by that? If a page is referenced, that will kept in the working set. If the page is not referenced for a period of time, then that particular page is deleted from this particular working set. Okay, so let's see here. The d is total number of frames that are demanded by each processes. Okay, the total number of demand of a process. Okay, demand of frames. And WSSI is a working set size for each process. That means P0, it working set will be 5. P1, for each process we need to define a working set size, so that these number of pages must be present in the main memory. Okay, the operating system defines the working set size for each and every process, and it will monitor the working set size, and it will allocate the frames initially. Okay, then let's see this one. D, that is total demand for frames. Total demand for frames equal to working set size of each process. That means if P0 having this one, so WSS of 0 equal to 5, then WSS of 1 equal to 6, WSS of 2 equal to 8, WSS of 2 equal to 8. Okay, so what is d? D equal to sum of 5 plus 6 plus 8. 5 plus 6 plus 8, this will be total demanded frames. Okay, then m is the total number of available frames. M is the total number of available frames in the main memory. Okay, so the operating system monitors the working set of each process and allocates to that particular working set. Okay, to each frames. Okay, each process, the working set number of frames will be allocated. Okay, so after allocating, if there are any extra frames, and one more, it will operating system allocates these frames to other processes. Okay, now we look into here. D is the total demand of frames, and M is the total number of available frames. When the demand frames are greater than, the demanded frames are greater than total number of available frames. Total number of available frames. What is mean by that? If all the processes, okay, sum of all the processes that is demanded is 60, but we have only 50 frames are available. Only 50 frames are available. Then the system will go to thrashing. Okay, the thrashing problem comes when d greater than m. Okay, now what will happen in the working set model? The operating system will select a process. Okay, and suspend that particular process. Will select a process, one process, will select one process and suspend that particular process. And after that, the pages that are belongs to that particular process will be swapped into hard disk, will be swapped into hard disk drive, that is your backing store. Okay, then once the pairs are swapped out, the frames will be empty, frames will be free. Okay, so these frames will be allocated to other processes that are currently resided in the main memory, currently resided in the main memory. So this way the working set model prevents thrashing. Okay, prevents thrashing, and it keeps degree of multiplexing high, as well as the CPU utilization is also high. Okay, so